Part 3. Whoops.
Thank you.
All right. Oh, this looks ugly, doesn't it? Next page. Let's jump down to the question so I can explain what we're doing, and then we'll back up to the formula. So sometimes we're permutating objects, but we're not permutating all the objects. So this example says the number of words, we say words in math very loosely, it's just any letters put together. They don't actually have to be a word in the dictionary. With no repeaters, but they're formed from, so 5 letters, formed from the letters of the alphabet. So, how many letters are in the alphabet? 26. So, P stands for permutate. 26 is how many letters are in the alphabet. How many of those are we going to move around? 5, right? It says 5. So that is the notation that says we're going to do 26 permutate 5, because we're not doing all of them. Okay, so now we're going to back up. We actually have not done this formula before, but we have done this one when we learned binomial theorem. Do you guys remember the n choose r? Okay, we actually use this formula, but we haven't used the permutation one. Permutation one looks like this. You have to know the formula because sometimes on testing, it wants you to recognize the setup. So if you don't know the formula, you won't know the setup. But you also need to know how to use your calculator. You have to know both, okay? So this is a formula for permutating. So let's practice plugging in to that. So what's gonna go on top? If we have 26 permutate 5.
5.
What goes on top?
5 factorial.
The 26. So 26 factorial, right? That makes sense because that's permutating all the letters in the alphabet. But we don't want that. We need to divide out the ones we don't want. Does that make sense? So what we don't want isn't the 5, it's the other ones. So that would be 26 minus 5. Does that make sense? We're dividing out what we don't want. 26 minus 5 is 21 factorial, is that right? Okay. Now, we're not going to touch our calculators yet, but I want to remind you guys of something to do with factorial, and then I will let you use your calculators. Remember what 26 factorial represents. It's 26 times 25, 24, 23, 22, 21, dot, dot, dot. I just stopped there because if you're dividing it by 21 factorial, what's going to happen with this whole part? It's going to cancel, no. That 21 factorial is going to cancel with 21 on down, so all you're left with is that part. Does that make sense? So it's really a bunch of canceling. So go ahead and use your calculators. 26 times 25 times 24 times 23 times 22. And then I'll show you a faster way. It's a pretty good sized number. You ready? I'm going to write it sideways. 7, 8, 9, 3, 6, 0, 0. Is that what you guys get?
Yeah.
Okay. Now that would be a setup question. Like they might give you the information given. You would either have to choose this, or you would have to choose the 26 factorial over 21 factorial, or they could give you this and you would choose that. If you're gonna, because you can't multiply those in your head or nobody's gonna ask you to. So if you get your calculator though, let's back up. Let's practice putting this in without the plugging into the formula. So you guys should have an NPR button on your calculator. If you're using the school calculators, it's under the 9. If you're using when you found the factorial and you had to hit the probability key, that's also where the NPR button is. Okay, but try plugging it in. So on this one, on a school calculator, you would put in 26. You would hit second 9 to get the NPR. Then you would plug in 5 and you would hit equals. And you would get that answer automatically. So try it. 726 per 5. So give it a try and try.
So you pick the number and then you pick the second and then NPR? Or number? So which one are we doing? 26.
Anybody not get it? Or need help?
I would just put 5 and then equals.
Right here.
See if that does it.
So you do 26.
Oh,
All right. How about 22 permutates 7? With your calculator. I don't have the answer to this. It's 8, 5, 9, 5, 4, 1, 7, 6. Oh, it's big. You guys get that?
Why the heck? We were singing, right? Sorry.
It's okay. It's a lot of permutations, right? Okay, so permutations, order matters, okay? So there's a lot of them. You can see the numbers are huge. What's the difference between that and combinations again? Order doesn't matter. So there's a lot less, okay? There's gonna be less combinations because every time a permutation rearranges as it counts it again, the combination says that's the same thing. It's the same thing, it doesn't matter. So that's why on N choose R, we actually are taking the permutation formula and dividing out not just the part you don't want, you're dividing out the part that is the same and just switching places. So we actually had this formula first semester when we were doing binomial theorem, okay? All right, so here we go, here's some examples. We're gonna use our calculator for all of these, okay? So we can do it the easy way. So how many combinations, that's the key word here, because as soon as it says combinations, does the order matter? No, order doesn't matter. Order doesn't matter. So combination says, we don't care whether it's ABC or CBA, doesn't matter because it's the same 3 letters. So how many ways are there? There's 1. There were 6 permutations. And I know that's hard to wrap your mind around because you're like, well, when you switch it looks different. But it's the same thing. If we go to use the formula and choose R, watch this. Out of those 3 letters, you're choosing those 3 letters. So try that on your calculators. You guys have an N choose R button. It was probably right next to the NPR button. Put in 3, N choose R, 3, and equals, and I guarantee you get a 1. You have to use the N choose R button, not the NPR button. You should get a 1. N choose R. You should get 3, choose 3, you should get a 1. Did you guys get 1? All right. Let's do the next one. My favorite ones are the ones that have to do with cards. If you're dealt a hand of 5 cards from standard deck, we're talking about poker here, people. How many combinations are there? So when you're dealt cards in poker, unless you're playing Texas Hold'em where order does matter because you see the flop, blah, blah, blah. But in a standard game, it doesn't matter what order you get those 5 cards because they end up being the same hand anyway. So what are we gonna, it's a choose, because order doesn't matter. How many are in the deck? 52. So 52, choose 5. Okay, go ahead and use your calculators. You've got to show me the setup, because on your homework, I've got to see whether you used NPR or N choose R. 2, 5, 9, 8, 9, 6, 0. There's a lot of different choices from a deck, right? That's why poker's always been such a big deal, like, you know, when people that like gambling, because it's hard to get certain hands because there's so many options. Did you ever get that? Okay, we're almost done. All right, next question. How many 3 letters can be chosen from the alphabet. So we did, before we did, that was 26, permutate 5, so this is gonna be a lot less anyway. But how many are in the alphabet?
26.
And we're permutating 3. Use your calculators.
2,600. Wow.
Are we okay? Okay. All right, last 2. So I want you to think about keywords, and then is it a permutation or a combination? A swim team is gonna send 2 people, let's circle 2. How many ways could the choice be made from Sarah, Tony, Juan, and Bob? So is this a combination or a permutation? If you're chosen, is the same thing happening to you guys or something different happening to you guys?
Same thing.
Different.
If you're chosen, what happens? You're going to the finals, right? As long as you're chosen, you're going to the finals. So it's the same thing happening. Does that make sense? Because you only care about the people being chosen, okay? So it's choose. So how many are we choosing out of? 4. And how many people are we choosing? 2. Or choose 2. So use your calculators. Alex says it's 6.
There you go.
Okay, and then the big finale. So we've learned how to count today, different ways to count depending on the wording. Now we're going to tie it in with probability. So here we go. What is the probability? So as soon as I see probability, I'm going to set up a fraction, aren't I? Because probability is always a fraction, what we want over the total. 1 over the total. Okay, you're dealt 5 cards. So again, when you're dealt cards, do you care about the order? You don't care about the order, so it's a combination. Because you don't care. And then we want to get the 10, Jack, Queen, King, Ace in the same suit. That's called a royal flush. Really hard to get. Worth a lot of money if you do get it. So let's talk about the denominator. So we have to think of all the ways you can be dealt 5 cards. So what does that look like? Say it again. Well, it's not 52, it's 52, choose 5, right? It's a combination. So there's 52 cards, all the ways they can give us 5 cards. So the bottom is 52, choose 5. Now on top, we gotta hold off, because on top, we get to make it happen. Like, we get to make the thing happen that we want. The first thing is they all have to be the same suit. So remember, there's hearts, diamonds, clubs, and spades. We need to pick one of those. So how many ways are there to pick one of those? 4, choose 1. Does that make sense? That's picking the suit, whether you want diamonds, clubs, spades, or hearts. So you've got to do that. There's 4 ways to do that. 4, choose 1 ways. So we're going to assume now, writing that down, that we have all the same suits. So now we have to choose the exact 5 cards that we want. 5 cards we want. How do we do that? How do we make sure we only get those 5 cards? Say it again. Okay, so everyone thinks it's 13, choose 5, but if you pick out of the 13 of whatever suit, isn't there a chance you're gonna get the cards that are 10, Jack, Queen, King, Ace? So we have to limit it to the ones we want. So how many? 5, choose 5. That's the only way that we can guarantee that we're getting those exact 5 cards. Does that make sense? So it's very specific. Now, if I were you, I would do this separately on my calculator, although some of you aren't gonna listen to me. Like 4 choose 1, I would do that, that would be a 4. 5 choose 5, that's actually gonna be a 1. 52 choose 5, we did it up above. It's the big number, 2598960. And then when you divide that out, smallest probability we've ever seen. Does that make sense? It does make sense if you know anything about cards, because that hand is incredibly hard to get. Okay? It's like playing Yahtzee, if it wasn't just trying to get a straight, right? You were trying to get it, and the dice were different colors, and it had to be the same color in those. Like it would just be so difficult. Okay, if you're having trouble with your calculator, go ahead and stop that. If you're having trouble with your calculator,